everyone.
Hello.
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 Can I please ask you to turn off your microphones for a second, please? We are just about to start. Okay, welcome to our session 15 at ZeroBuild Turkey. Our session is entitled BIM-based Design Practices and Strategies in Zero Energy Buildings. My name is Kutlar. I'm a Master of Science Architect and completed my Master's in Architecture and Sustainable Environment in the UK in 2015. And since then, I'm actively working in the sustainable building sector as a designer, consultant, and researcher. I'm a certified passive house designer and have experience in green building certifications. I use BIM tools as the backbone of my practice to calculate building performances. I am constantly developing my skill towards sustainability and just established my own company, Grid and BIM Limited in London. I am also head of Architects Network in ZeroBuild Turkey. BIM plays a very crucial role when we talk about zero energy buildings. When we say zero, we actually mean that. In order to achieve such an ambitious target, we really need to design everything in detail, considering not just the design stage, but construction, operation, and maintenance phases. BIM allows us to carefully work on these stages and come up with the numbers. This session's presentations are going to show us how to use BIM tools through their life cycle, including existing and new buildings. Also, we will grasp an idea about how artificial intelligence and digital twins can help us to achieve our goal. I have 4 international speakers that I'm extremely proud of chairing their sessions. And I would like to start with Associate Professor Dr. Gülsu Ulukavak Harputlugil. Since 1998, she has been working as an academic researcher. She has a PhD degree in architectural science in 2009 from Gazi University, Ankara. In 2005, she worked as a visiting researcher for 6 months in the Building Performance Simulation Group of Eindhoven University of Technology in the Netherlands. After PhD, she worked as a postdoc researcher for 6 months in Delft Technological University in the Netherlands. And recently, she is working as an associate professor at Çankaya University, Faculty of Architecture, and responsible of several undergraduate and graduate courses, including architectural design studio, building science, construction systems. She has a wide academic background in the field of sustainable architecture, ecological design theories, and building performance evaluation, performance simulations, and has a strong knowledge on building physics. She has been participated in many national and international research projects as a senior expert in the relevant field. She is married with 2 children. I would like to kindly ask my speakers to turn their microphone, except from Gülsu Hanım. And now it's your turn.
Thank you so much, Mrs. Kutlar. It's really great to be here in that nice and very important organization. So let me share first my screen for my presentation. Yes, I hope you are seeing my screen at the moment, I hope. So I just want to start my presentation, today's presentation. Good afternoon, ladies and gentlemen. First, today I'm going to talk about performance evaluation and simulation of zero energy buildings. What's performance and what's performance evaluation, why this is important and how we can deal with it on the way to achieving zero energy buildings. Actually, before starting the point, I start with this very important and essential issue for our planet. We are actually at a war with nature, and if we win it, we are lost. So this is a very important point for us to understand the background of all efforts in saving the Earth. However, we don't need to be pessimistic at all. There are several opportunities that we insist on the principles of each. There will be a chance for our future. For instance, improving current building stock is as important as the rules for new buildings. countries, governments, actually, their 2030 and 2050 projections are showing the direction of increasing renewable energy, climate-sensitive and adaptive urban settlements, nearly zero energy building principles, smart buildings, and the technology it brings to our life. Oops, sorry, I think I stopped the share. Sorry for that. I will go on.
It's okay, we are waiting for you.
Okay, sorry. Now it's okay, I think. Now, actually, let me start with talking about several common issues all of us come across nowadays. First one is the climate change, for sure. I'm sure that almost all of you know more or less about climate change nowadays. In media, this is one of the hot topics of the news. Recently, we know that temperature of the earth is increasing. Extreme weather conditions are increasing. Drought and wildfires are increasing. Sea levels are rising. Ecosystems are changing. In these circumstances, we as the professionals who are responsible to build the environment need to develop action plans for the future immediately. We as individuals have to decrease our carbon footprint. Moreover, COVID-19 pandemic emerged as a new threat and impact the world. COVID-19 is not the first, and we should be sure that not the last virus that causes a pandemic. So we should also need to be ready for the issues caused by pandemic. This is not only a health issue, actually. It requires a new approach for professionals who are responsible for the healthy environment. They need to change all their perspective and practices. In this content, an approach that takes into consideration the comfort and health conditions in the built environment should be put into practice widely without wasting time. Regarding to our profession, for sure we need to have a perspective from building sector. But there is a reason for that. It's obviously seen that building sector is a single large contributor to carbon emissions. According to International Energy Agency report, the building sector represents 30% of global final energy consumption and 28% of energy-related carbon dioxide emissions worldwide. In order to understand buildings' contribution to greenhouse gas emissions, we first need to remember the resource and material flow in the buildings. Here you see there are upstreams, the resources for the building up and operate buildings, like materials, energy, water, and downstreams, which are the wastes or byproducts, like used materials, garbage, heat, waste, water, etc. We need to focus not only the processes in between as building itself, but to consider reducing the resource consumption and minimizing the waste production. This needs a new understanding of design, construction, and operation process for the buildings. So what we are seeking for within this understanding, on the way to achieve zero energy building, the essential key points are energy and resource efficient buildings, for sure, at the first sight. The building with its all components and systems should be designed in a manner of consume as less energy, water, material as possible, near to zero maybe, even produce its own energy if possible. Non-wasteful and non-polluting buildings. Not only being not wasteful in operating, I mean the occupied period of the buildings, but starting from obtaining materials from the nature, producing it in factories, transferring them to construction site. All the processes should be ideally non-wasteful and non-polluting. Sustainable design that helps minimize broad environment impacts, also in an overall perspective. Considering the reality of climate change and its effects on environment brings responsibility for the future. Highly flexible and adaptable for long-term functionality is another process. The adaptability is the only key factor for the buildings, which helps us to cope with the predictable and unpredictable effects of climate change in the future. Easy to operate and maintain, especially from the cost perspective. For the buildings, not only the investment costs, but also low running costs are the crucial requirements for the need to be considered. Supportive of the productivity and well-being of occupants. Occupant comfort and well-being are the measure factors for the buildings. The prerequisite of all those precautions is maintaining the comfort conditions of the occupants. Because all those efforts I told you here is valuable and makes sense, if they meet with the minimum comfort expectations in the indoor environment, makes sense. In order to achieve a zero building in the perspective that I define here, a very important several points need to be considered. First of all, as the buildings are composed of several subsystems, the system integration and a holistic approach is very essential. From very early phases of design, an interdisciplinary effort and be aware of each system in relation with others is a critical point. Secondly, understanding of what is building performance. What are the parameters of performance? How will the assessment and evaluation of the performance will need to be considered, must be well known. I will give a detail about this performance later in this presentation. But the last but not the least is the people. So also I told that well-being and comfort of the occupants are the prerequisite of all these efforts. We should be aware of that. So let's come to the point regarding to the performance. For sure, there are various types of definition in its related field of performance. And the general definition in the dictionary, as you see here, is how well a person, machine, etc. does a piece of work or an activity is a general definition. But we are now talking about building performance here. So as a building performance and a performance approach, the main acceptable definition is done by CIB in their report of working with the performance approach in building. The performance-based approach is the practice of thinking and working in terms of ends rather than means. Actually, in other words, we can make an explanation of that. Performance is a result which we need to seek for. The performance approach is a practice of thinking and working on the basis of results rather than method. It's concerned with what a building or building product needs, not a description of how to construct it. So here, actually, for a performance approach, we need to change our language, as there's simply two different languages, we can say. The user requirement language is a language that the user understands well and often reveals the necessity for the function. On the other hand, performance requirement in an expert language that makes no sense to an ordinary user and translating user needs into performance requirements, and it requires a high level of expertise. The performance requirements defines different approaches for the level of quality required during use of the building, but doesn't suggest any solution. This enables creative solutions in the design and engineering processes. To ensure that these solutions meet performance requirements, it's necessary to evaluate them. This is done on the basis of performance indicators. These indicators can be created from proposed design solutions with the help of measurement, calculation, or simulation methods. Achieving that performance, it is crucial to have an integrated design approach perspective, which includes that the technical team and all stakeholders involved in the design process should be able to continuously evaluate the design in terms of cost, quality of life, flexibility, environmental impact, productivity, creativity, and user comfort by working together from the very beginning of the process. During design, the design team with its all stakeholders should dedicate to integrated approach for high-performance building. Here, the performance evaluation is critical. The reasons of performance evaluation to achieve improving energy performances of current building stock, not the new buildings, but the current building stock, using energy-efficient appliances system solutions, developing ends up nearly zero energy building strategies and life cycle assessment strategies as well, providing climate-sensitive and healthy urban settlements, renewable energy technologies, and smart buildings, and for sure, IoT interaction, which is very, again, important nowadays. In this point, we need to know that there are several tools that will help us to achieve and evaluate building performance. These are in a wide range of applications, but today I would like to focus more on building simulations. Building performance simulation is a method of analyzing the performance of building by simulation in order to predict the behavior of the real system using a specialized computer program. Building performance simulation enables the performance of new ideas and design alternatives to be tested much cheaper and faster than physical experiments. Building performance simulations test the real problems that may occur in the building systems and the comfort of the building users by simulating the internal and external conditions. Performance simulations is not a representative of the performance or any building in 3D modeling. It has a very complex calculation methodology at the background of itself. And you see in the screen that the differences between representation and simulation. And also building simulation helps to calculate the very complex engineering models in an easy and fastest way. Actually, for the buildings, there are several levels of performance requirements which need to be evaluated. Here on the lowest level, you see the EPBD criteria, I mean the Energy Performance Buildings Directive criteria, which is defined in Building Energy Performance Regulations. This is a must of energy certificate, and any of the buildings should maintain those conditions. But to be honest, this is not enough for the high performance or zero building achievements. At the upper side of this triangle, the performance expectations getting higher and more complex tools for performance evaluation is necessary at that point. There are lots of tools which may help to understand the real performance of the buildings, interactions of the systems, etc. I put here actually a sample of them, but be sure that hundreds of other programs, some which are dedicated to spatial performance, for instance, acoustical or lighting design, while some others are simulate whole systems together in its own complexity. Nowadays, we are in a point that the building performance evaluations and building information modeling systems, I mean the BIM applications, need to be interact to achieve the high performance on the way to zero energy building. Building information modeling enables constructing a building designed in a computer. A building information system is a project simulation that includes 3D models of project components to which all necessary information is associated with the planning, construction, and operating processes of a project. Building information systems is a process of production, storage, management, exchange, and sharing of building information in a reusable way. The building information system provides the user with the integration and reusable of building information and site information through the life cycle of the building. The most basic feature of the building information system is that it's a 3D modeling system that includes data management, data sharing, and data exchange throughout the life cycle of the building. Indeed, it consists of geometric elements that form the basis of a building design. In fact, parametric modeling provides a powerful mechanism to automate the generation of structure information. This mechanism, especially related to building object behavior and object-based system, facilitates the validation and repair of the building design. With geometric modeling,
wrap up in 2 minutes, please.
Yes, I am about to finish. Thank you.
Right.
With geometric modeling and computer-aided product methods, Design and forms that would be possible without computers are made possible. With building information modeling, it's possible to obtain not only good-looking, but also correctly designed buildings. The integration of building performance analysis within the design process enables the full use of computer methods in architecture. Perceiving the building as a system by seeing the complex relation enables new approaches in architecture. As for the last words, we are in a new era. Whether sustain a livable environment or destroy it is exactly in our hands. We have no choice without selecting a sustainable, healthy indoor and outdoor environment. In order to achieve this, zero resource consumption, I mean zero energy, zero water, zero emission should be the objective. Here in this point, performance-based approach will help us to optimization and integration of the things, whether fan speeds or fire safety, whether landscaping or lighting efficiency. High performance means thinking on both the micro and macro level about how building systems interact and how building occupants interact with those systems. Considering all these requirements and expectations from the buildings, recent approach to building design can be summarized as form follows performance. We don't forget that the performance expectations lead to all other traditional visions and dominate on them on the way to achieve zero energy buildings. Thank you for your attention. I finalized here and stop my sharing.
Okay, thank you very much for this informative talk. Now it's time for Mr. Aydın Özçekiç. I would like to make a quick introduction. Okay, so he's a civil engineer. He has a master in construction management and the second master in business administration. He has more than 10 years of experience in the construction technology area. He has worked as a technology consultant in different contractors, and his expertise areas are BIM, planning technologies, and artificial intelligence development. He is the founder of Botmore Technology, which is producing artificial intelligence-powered construction technology solutions for contractors. Now it's your turn.
Thank you very much. Perfect introduction. And presentation was perfect. I like to listen to it. And now I want to share that. Just a minute.
Okay.
Just a minute.
We have some questions also, but we will talk about them later. We see that the visitors, the audience are asking questions. Okay.
I couldn't do that. Just 1 minute.
Okay, it's all right.
Okay.
Meanwhile, maybe we can ask a question. Maybe it's not easy to answer like quickly, but that comes to Gülsu Hoca. That
yes,
it's,
sure.
Yeah, it's about weather data. So Dr. Levent Yalçın is asking how much of the weather data you are using in the simulations, in those softwares that you mentioned earlier.
Yeah, actually, the main point and the very critical point of using this kind of energy performance simulations is the weather data. It's very important, and you should be trust to your weather data. And also, each of the program needs several different types of weather data. Even some part of these programs use monthly data. Some part is just need very detail in a hourly based data. So, but nowadays actually this kind of weather data are in TMY or TM2 in a way that this kind of type of the data can be used in almost all the programs, in simulation programs. But actually, for the Turkish or each of the location when you are seeking for weather data is not always possible. For instance, for each of the city, each of the sub-city of the Turkey, it's not possible to find the correct and hourly-based data. And actually, it is necessary for our meteorologically administrative people needs to be work on that for the Turkish, for sure, data. But on the other hand, most of the data can be possibly found in a freely way for the buildings, for the programs that you can use.
Okay, all right. Thank you very much. Now we can turn back to Aydın Özçekiç.
Yes, sorry for it late.
It's all right.
Yes, I'm starting now. Today I will talk about BIM-based design in zero energy buildings. You make a wonderful introduction. So my name is Aydın Özçekiç. I'm founder of Botmore Technology. Today I am living in UK and my projects in UK too. So I try to give some examples from UK and try to explain what we are trying to do and how it is working on UK. How is the approach of UK government and UK contractors to these works? Basically, according to research carried out by the Center for Economics and Business Research, the UK's built environment must reduce its energy consumption by around 80%. If it is to meet 2050 net zero carbon emission target. UK government put perfect targets for the companies and for the ecosystem to reach, and there are step-by-step plan for them. And as you see on the presentation, they put some milestones for the building sector. And in 2025, no new sales of fossil fuel boilers. 2030, universal energy access, all new buildings are zero carbon ready. 2035, most appliances and cooling systems sold are best in class. 2040, 50% of existing buildings retrofitted to zero carbon ready levels. 2045, 50% of heating demand met by heat pumps. And 2050, more than 85% of buildings are zero carbon ready. I think this is a very structured plan, and it is good to see that kind of plans because it forces all industry to change. And of course, it is a sample from the UK, but of course, other countries, other regions are working that kind of standards too. So now in the UK, I see that these targets are not roadmap affecting all ecosystem contractors or supply chain, and people are trying to find solutions to fulfill these requirements. As you know, the construction sector is very not in easy sector, and coordination is not so easy. There's a big coordination problem on the sector, and small changes affecting everything. There's different partners, different parties working on same project, designers, project managers, and owners, and subcontractors, and they make all changes about on the project, and this strictly affect the project, and it creates problems on the construction side and implementation especially. So as you see on the cartoon, we are looking for green back, but unfortunately we can take red back, and we can have a sandwiches when falling down. So in the construction sector, people living these problems is so normal. So I think the main answer is common data environment. This is theoretically the answer of all problems, because if we can create a common data environment for all project contributors, it will be easy to manage all projects, and everybody can reach the data easily. But of course, this is not easy as we see, because it's a bit problematic, because all different parties should contribute to the system. And of course, there's a technological side of this problem, which is, of course, it can be easily solved because it's generally a data management system. But on the other hand, it's a contractual issue. Contracts should put common data environment to the center of the management. I think is important. And unfortunately, there are problems in that area. Governments are forcing it, but there are standards already in the sector, but unfortunately, it doesn't work properly at the moment. I think all over the world, but people are trying to put common data environment at the center of management process. And you know that there are a lot of decisions taking on the construction side. That now we have a design, and we create a design on the designers create design, and then this design carrying to the construction side, and then implementation starting. And 35% of decisions is taking in 1 hour. 45% of decisions are taking instantly. So this is very critical for the success of the project. And people have to give some decisions about material selection or finding an alternative method for production, and all depends on their experience. Unfortunately, green building and sustainability are new concepts for the construction teams, and their experience are more traditional. So they are finding solutions not so suitable to the green building concept. So this is one of the big challenges for us to solve, because we can make wonderful designs, but we couldn't carry it into implementation. This will be a huge problem for everybody on the sector. So,
Aydın Bey, could you please turn off your camera? We are having an issue, but we are listening to you.
Just Is okay?
Okay, yeah, but yeah, please presentation mode. Yes, it's working. Thank you.
Okay. So decision support for sustainability is critical in that point, because we are taking a lot of decision about sustainability, and we need support using the technology and of course data. Again, I want to turn back to common data environment in that point. If you can create common data environment, we can prevent rework. Rework is one of the most important problems of the construction sector, and total cost of rework is 6% of construction cost. According to FMI research, miscommunication and poor project data accounts for 48% of all rework. This means that just we can properly implement common data environment to the construction projects, we can decrease cost 3 or 4%. I think this is very critical, because if we can do this, first we can reduce the cost of the construction, and secondly we can create a solution for the sustainability, because this cost decrease and common data environment, it creates an opportunity for us to use different methodologies which support sustainability of the project. And if we come to the BIM, now we are talking about the BIM more than 10 years. And of course, BIM is relatively new, but not so new concept. We are using some parts of the BIM on the project effectively, but BIM is not just a visual thing or just not for the analysis. It is a living thing which you can use in the project and all parts of your project, all steps of your project. So now you can use, of course, BIM in building, orientation building, massing, daylight analysis, water harvesting, energy modeling, and already you are using that. But for the sustainable material selection, for the logistic management, for the sustainability management, we can't use BIM effectively at the moment, because we couldn't put BIM to the center of all production. It seems like that it is a part of the design. It's not just part of design. It should be center of the all construction project. And we talk about the common data environment, and the BIM is the center of the common data environment, which provides data for all parties. And if we can focus, for example, logistic management, we can optimize carbon footprint of the material management side. I think that kind of things are critical for the success of sustainability plans, and we have to use BIM in different parts of construction, and we should work for it, we should force for it. And of course, just not for the contractors, government should force it too. And of course, being related to sustainability, I want to give an example about it. According to Sweco head of sustainability, Matthias Goldman, BIM helps to minimize our environmental impact across the entire process and ensure all information about the building is digitized. The data can be referenced in the future to glean learnings and pull information across different projects to keep a record of the most sustainable materials and methods. I think this is very critical because we have to create a pool information across different projects. We couldn't do this at the moment, but we have to do this because if we can do this, we can keep the records of the most sustainable materials and methods. And this is another important thing because if we don't understand which methods are more sustainable, which materials more sustainable in real life, we couldn't solve our problems in long term. So because of that, BIM is important because as you think again, BIM as central database, we can create a recording system for our projects and of course for our portfolio. And of course, other thing is carbon reduction. As of course, I want to give another example from Graham Watts, the Chief Executive Officer, Construction Industry UK. He said that BIM will integrate the construction process and therefore the construction industry, but it will also have many additional benefits for the nation. It will enable intelligent decisions about construction methodology, safer working arrangements, greater energy efficiency, leading to carbon reductions and critical focus on the whole life cycle of the facilities. Of even greater importance are the benefits for the economy that will occur from the better buildings and infrastructure delivered by the construction industry. As you see, we should position our BIM implementations differently because if you can do this, BIM can work in the different points for the sustainability and green building concepts. And digital twin is another concept which is important. Then it is, of course, BIM is a part of digital twin, but digital twin is adding a new layer top of the BIM, and now we can use IoT and Internet of Things and the sensors to collect data from the real building and to use this data in our digital model. And we can understand what is going on the real life. And of course, we can make some optimizations on our assumptions. This is again very critical for the success of long-term success of the companies, of the, governments, and of the owners to understand that kind of things. Because sustainability analysis just depends on the data is important, but we have to see real life results of these analyses. So because of this, digital twin is an important concept, and I believe that it will change a lot of things for the optimization and for in the long term for the construction productivity. And again, according to UK government decision from January 2021, a minimum weighting of 10% of total score for social value should be applied in the procurement to ensure that it will be differentiating factor in bid evaluation, and higher weighting can be applied if justified. This is another important thing. Now our tender process should be changed because in cost-based tendering and is very dangerous for long-term sustainability. So especially governments and the big private owners should put that kind of rules to their tenders to change their system for more green, social, and sustainable criteria. Now, Botmore technology, which we are working on generally for artificial intelligence, how we can use artificial intelligence in different points of construction sector. And BIM and AI is, of course, is so related. First of all, I want to say that artificial intelligence is a reachable technology at the moment. It is not a science fiction. You can develop projects easily using different machine learning algorithms. So we have to use this kind of technologies to make a better projects and to increase our, of course, productivity. For example, the first impact of the AI in the BIM is BIM data labeling and auto check. You can think it like auto-correction, auto-spelling in the Word documents. So auto-check is generally using the past data experience in your modeling experience, and then it tries to understand mistakes on your project, and it makes some suggestions about labeling of the objects on the BIM. This is very, very critical, because if we can increase the quality of the model, then we can use this model effectively other stages. So these auto-check systems increase productivity on the modeling side and increase return of investment of BIM projects. And AI strategy. Generally, if you look from the government perspective or a contractor or designer perspective, you should understand that everything is changing so fast. Now, you can develop some models, but as an architect, but you are at the same time creating a database, but it's not enough. You are working on this data. You are taking some insight from it. So you start to think about how I can use AI in my works, in my daily works. It's not just a big deal. It starts to be as a standard procedure of daily works. So try to understand how you can automate your systems and you can solve your problems. It's the same for the big things, for the project managers, for the government side. Every player should think about how we can develop AI-first projects for our construction projects and, of course, designs. And we try to create a concept for our customers, of course, but generally for everybody. We try to, first of all, you identify use cases for your projects. It's about the sustainability, it's about the green building, it's about the net zero energy buildings. All of them is the same. You have to create some use cases. You have to define your problems. Don't focus on the technology. I think it is a mistake. You focus on your problems. And then select 3 quick win artificial intelligence case for company or for project. And select a proper technology, pilot, test, and go live. You will see that there is a different recommendation systems now AI can provide you. For example, material selection especially is important. Supply chain optimization is another step for the AI you can use easily. And that kind of usage is possible. And now smarter construction services are coming. What I mean, smarter construction services. Now, traditional construction services, try to design, build, and operate some steps, and they try to solve the problem of the construction. But smarter construction services generally focused on the data and optimization of the process using different technologies. That kind of services are increasing, and they are changing the sector. And we will see more example about it in the near future in UK and Europe. And construction process optimization is a critical problem, and people are working on it so much. And AI has a crucial role in this problem, because if you have data, we can solve a lot of problem on the construction side using this data, and we can make a good optimization on the processes, and we can shorten the construction times, and we can decrease different KPIs. We can define different key performance indicators for our project, and we can fulfill these KPIs. Yes, generally I try to explain these points. I try to touch generally UK implementation and problems I solve in the sector. I hope you like it. Thank you very much.
Thank you very much. It was very good, very interesting and technological, of course. So now it's time for Paula Baptista. I would like to invite her. She's a diploma engineer, specialist architect for energy efficient building international, working at the German Energy Agency in Berlin. Trained in architecture and urbanism, she has a Master of Science in Building Performance and Design, and further specializations in field of integrative technologies and architectural design research. Her professional experience includes integrated planning, design, construction for sterilized hybrid timber systems, sustainable construction methods for high and low-income housing, as well as serving as a green building certification consultant. Her work was taking her to Europe, the Americas, and most recently, Western and Central Asia. Now it's your turn, Paula. Thank you.
Hi there. Can you see? I see you can see my presentation.
Yes, we do.
Okay. Is it slightly smaller than it should be? No, it's fine, right?
Yeah.
Okay, so thank you very much for the introduction. I would like to discuss with you a little bit of the more analog side. I'm going to give you a case study that we worked, that happened here in Germany that showcases how tight collaboration, such as in a building information modeling type system, can be effective. So in energy, in Germany, as well as in the rest of the world, we have a population growth issue. We have, therefore, a rising demand for buildings. In Germany, the energy consumption for buildings is about 35%. Throughout the world, you could say that this could be on average 35 to 40, sometimes more, but it's around there. And Germany has recently set its climate target goals as to reach carbon neutrality by 2045, which is 5 years before the Paris Agreement. This means that for the German building sector, we need to reach greenhouse gas emission reductions of 80% by 2045. In Germany, the ministry is responsible for effectuating, let's say, I don't know if that's a word, my English and German are mixed now. For making this possible are the Ministry for Interior, Building and Community. They are responsible for construction, the Ministry for Environment, Nature Conservation and Nuclear Safety, for climate protection, and the Ministry for Economic Affairs and Energy, responsible for energy. Together, they work in cooperation and individually to achieve a holistic outlook of the situation in Germany and to apply their respective measures and standards, and also provide the incentives to make it possible for public and private investors to actually achieve these targets. In Germany, they started working on this issue actually a while ago, before 1980. As you can see in this chart, and it's important here to see that each of these steps, this is an improvement of the standards. This doesn't happen, this needs to happen like this, because this is a stepping learning process. So you set standards. Sometimes you need to take a step back. Sometimes you see that you're able to take a step further. And you can see on the bottom line below the improvement, the gradual improvement, and the efficiency levels that we were able to achieve. I say we, because I'm just proud of being here. Germany has been able to achieve. And you see a little bit of a projection to 2025. As with, traditional, I'm a Canadian architect, mostly. I'm a Canadian, Brazilian-based architect. So Germans are known for their very pragmatic, and this is true. So they don't make the projection too much further up, because we know that we have to take it step by step and evaluate every 2 years or so to see if we're reaching the goals. Each step, the way that these goals are evaluated, standards and requirements are evaluated, is looking at the building in a holistic way. So as this was mentioned before as well, unless you don't do this, you can't really tell where are the places where you need to improve. So yeah, you need an integrated implementation method, composed of groups of interdependent measures to see exactly how well and how fast you can, how good you are actually progressing with your goals. In Germany, it has been found that following these standards and methodologies and following this type of system, you can actually reach, both for new buildings and for renovations, a very, very similar result. Like this doesn't mean that you only need to build new, or this can also be achieved through renovation projects. The process is a bit different, but it can be done. And there, so since we're talking about, I want to talk about the existing buildings in Germany, since we cannot simply draw a blank slate and build from start, you know, energy efficient buildings. And this is a good example that was done in 2012. This is a building, a public social housing estate in Munich. This is owned actually by the GVG, one of the two big public social housing companies in Germany. And a characteristic of this project is the tight collaboration between universities, private agencies, private companies, architects and engineers, and government incentives. This project was done in 1 year. So they had to do a very, very tight, very, very foolproof method. Also specifically because the residents had to move out of the state during the renovation. So this is what the three buildings are. They were originally three buildings with 3 stories. They were built in the classic post-war German construction methods and using construction method and materials. At this point, they had to rebuild super fast. And so they built as fast as they could. And for example, things like heating, they were put afterwards. There was a little accessibility. There was a whole range of issues that do affect the energy efficiency of a building, which needed to be taken into consideration. Furthermore, this building was not only energy inefficient, it was also not interacting with this surrounding environment. It wasn't improving the neighborhood, it wasn't improving the livelihood of the people there. So that's the reason why they decided to renovate. The goals of this renovation were to improve, to re-densify. Most of the building tenants at this point were elderly people, and I just said that there was no accessibility. There's staircases there, so they were living in these poor conditions. They wanted to improve the kitchen, bathrooms, balconies, the environmental conditions of the building as a whole, modernize, and also increase the demography of the building users or the tenants, include a mix of people, which is also always healthy for a good environment, for a good urban setting. On top of this, they wanted to integrate renewable energy systems because it just makes sense. If you want to create or save as much as you can on a social housing project, that's what you can do. They set high standards. They did like a passive house standards and tests, respective tests. And they also use the modular construction systems to improve the construction site expedience. This is super important, again, because of the year. It had to take a year, and a year is actually quite short time to do a project such as this. So although this wasn't, they didn't use BIM, the BIM tool set, the digital tool set, they used the BIM principles. And this was quite successful. And another consideration that they had to do, because this was social housing, everything had to be low maintenance, easily accessible. And this is very important as well, because otherwise you can't have high-tech equipment in this type of setting and needing maintenance, and it's just going to break in 5 years, and that's no good. That's no long-term solution. So post-occupancy analysis was made. And actually, I've included in my slides always the pre and the post results, so which you can look at later. I'm not going to go into that level of detail right now. But basically, they had a prefabricated timber facade developed by TU München, Technical University of Munich students, and the companies together. They improved the windows systems, and they improved the roof and increased They had also like design changes, design optimizations, making the rooms inside bigger, increasing and implementing accessibility for the building, for the tenants. And you can see on the image, on the photos, actually, the thermic photos, the difference that it already made in this 1 year of renovation. The HVAC system was also improved, of course. This is very important. They had a central heating system installed. This is crucial for to be able to manage and to be able to control how much energy you're actually using and how much energy you're actually needing. They installed thermal collectors, photovoltaic systems. A very interesting thing and very important thing, tenants operation manual and integration with the tenants about how to deal with these systems and how these systems integrate. And you can see the possibility of these systems if this building was negative. If this building should produce more energy than it needed to integrate it to the grid. It is not the case, but it could happen. At an optimistic view. So in the end, I think I did an extremely short presentation. In the end, they were actually able to say, I say we sometimes because DENA also invested in this project. They were actually able to save 90% of the energy. And this is quite a substantial improvement, I would say, aside from the environmental factors and from the well-being, which actually consists of the whole sustainability, the holistic outlook. So this was a highly successful project, also because the cooperation worked. So the cooperation is possible. Of course, this would have been improved if we had been able to use BIM systems. In Germany, BIM, as far as I know, it's still, as in Canada, as in Brazil, it still has a long way to go because not every company has it integrated into their work system. And this, it's a tool. So as long as you have the principle, you can integrate the tool maybe a little bit more in sequence. And thank you. I think that's my presentation.
Okay, thank you, Paula, for the information provided. Now it's time for Dr. VSKV Harish. He is from the Department of Electrical Engineering at NetaJi Subhas University of Technology, Delhi, India. He had completed his ME with gold medal in power engineering from Jodhpur University in 2012 and PhD from IIT Roorkee in February 2017. He worked as a postdoctoral fellow at Terry School of Advanced Studies, New Delhi, during 2016 and 18. He has been nominated for the prestigious Young Energy Researcher Award in 2016 and 2018 at World Sustainable Energy Days, Austria. He was awarded Best Paper Awards at Springer and IEEE international conferences in November 2018, October 2019, and August 2020. He was granted international travel support by DST in 2014 and 2018 and by Soft Computing Research Society, India in 2017. He is also a member in various society and institutions like ASHRAE, IAEE, SIPSE, and CSRC. His research interests include building energy system and power system analysis. Now you can start sharing your slides. Thank you.
Thank you so very much. Am I audible and is the slide visible?
It's working properly.
Okay, thank you. Thank you so very much.
Can I please ask Paula to turn off your microphone? Sorry about that.
Oh, yes.
That's okay. Am I good to go?
Yes, you are.
Thank you. A very good evening from India and a very good afternoon to all of you. For the next 15 minutes, shall be focusing on the grid interactive building energy systems. I will be presenting before you a small concept where we have laid down the importance of buildings when it comes to the participation towards the electrical power grid. The idea being that one needs to understand that each and every building would account for some amount of electricity demand, and that demand would not necessarily always come from the on-site renewable energy, even if we talk about the net zero energy building. So what my focus right now towards as a research aspect is to attribute a building as a good grid citizen. At what level a building, any building of any functionality, it can be a commercial building, it can be an institutional building, a municipal building, a residential building, how to what extent can we attribute a particular building under a set of being a grid citizen. A good grid citizen would be a building that would assist in the flexibility of the grid. So the technical terms being the voltage supply, a good power quality, and also at a very nominal frequency, right? So these are the electrical based technical terms where the building can assist and thus help our power grid, the main power grid, to work in tandem. If we look into the concept of this grid interaction, uh, all the wonderful speakers have already laid down the importance of having a net zero energy building, importance of having a very good building information modeling, and also the significance of knowing a modeler or a designer should know which software to be used for which functionality of the building under study. And if we move further, we can understand that smart city is a concept that has been creeping up, coming up, and it is a concept which consists, it's a conceptual city that would consist of sustainable and resilient infrastructures. And here, buildings are a major constituent. Building energy consumption, if you look, contributes to more than 70% of the electricity usage. So it building as a subset will profoundly impact the power grid's operation, the main electricity network operation. Now, as buildings are physically connected to the electrical power grid, it is natural to understand their coupling, and let's understand development of a framework where it can be connected to the grid. So it's a grid interactive building energy system. Before that, let us have a quick look of a very famous buzzword that you would come across, that is called as a presumer. Simply put, a presumer is somebody who could produce and consume their own energy. If I would introduce the regulated definition by the Central Electricity Authority of India, which is a statutory body, comes under the regulation of Ministry of Power, Government of India. Presumer is defined as those electricity consumers who would consume electricity from the grid and can also inject electricity into the grid using the same network. Now, this technical definition, though, does not talk about on-site renewable energy generation, but it is quite understood by a large section of the society that it would have either solar PV battery energy storage or compressed air energy storage, or completely work towards 100% decarbonized society, right? And of course, consumers would be someone that would interact with the grid as a conventional form, in a very conventional form. Though all the honorable speakers have already introduced statistics about the building energy consumption all over the world, the global statistics, let me give you the statistics of the second most populous country in the world, that is India. Urbanization in India is resulting in increase of towns, cities, along with the rising population in urban areas. So the population has been rising. The construction sector has been rising because not only the horizontal floor area, but the vertical floor area is also increasing. Moreover, India is also the fourth largest consumer of energy after China, US, and Russia. And the building sector contributes to about 33% of the total energy demand that is coming from it. And out of that, residential buildings account for 24%, whereas commercial buildings account for 9% of it. There is again a large scope of building energy statistic evaluation when it comes to India, because very recently we have accepted buildings as a service sector. Niti Aayog, the Ministry of Planning and Statistics, and in its national energy policy, has first time regarded in 2016 as buildings as a service sector, and a lot of funds are now coming in order to get the adequate amount of data, because only then one can pursue and understand the potential of the energy savings. If you see the graph over your right side of the screen, this is a graph that shows a current scenario and also a projected scenario. And you can see that the electricity demand in terawatt per year, annual electricity demand, if taken the projection for the last 1 decade and looking for the projection for the coming decades, has an exponential growth. That means that the electricity demand will rise from 33, almost 335 terawatt hour per year to more than 4,000 terawatt hour, sorry, to more than 1,000 terawatt hour per year annual electricity demand in 2032. Also, I would like to garner your attention that buildings right now post-COVID scenario, especially in India, have garnered attention of having work on the air pollutants, that is the indoor air quality. So right now, ASHRAE, ISHRAE, and a large amount of research organizations are working together so that the chances of virus transmission inside the building space are as minimum as possible. So the HVAC standards for the mass flow rate are being revised now. Now that would again be energy intensive, which again would be encountering a load on our HVAC system, which gets primarily works on electricity from the grid. So hence again, the grid interaction becomes very much important and significant. Now, if we look, where do we stand when we talk about the smart grid scenario? If we look into the technical definition of smart grid from the Ministry of Power's website, Government of India, it defines smart grid as an electrical power grid which has the capability of automation, communication, and information technology systems in order to monitor the power flows from the generating power plants up till the consumption points, even down to the appliance level. That means the Government of India recognizes that yes, we would be able to achieve a smart grid scenario only when the company or the utility, the distribution company or the utility, would be able to monitor the demand pattern of the appliances as well. Up till right now, all over the world, majorly, except few pilot studies in few states, we have the distribution utility has all the power up till the meter. After that energy meter, you may call it as a smart meter or a prepaid meter. If you are using electricity, which device or which equipment is demanding electricity at what period of time is not completely known to the distribution utility, other than having a strong demand response based algorithms, which are price based incentives, right? So this grid interactive building energy system also assists in the smart grid scenario of the Government of India. And when we monitor this, the main target or objective of monitoring this power flow is to control active power and reactive power in order to match the generation and demand, ideally at all times of the day, or working in reliability with 100% reliability 24/7. Now, if we look into the net zero energy building scenario, the given definition, as you could see, as already it has been introduced by the speakers before, the actual annual delivered energy should be less than or equal to the on-site renewable exported energy. Here, one of the most crucial point is to understand the boundary. What should be the boundary? At what point should I encounter or install my meter? Because with advent of demand response, demand side management, energy efficient strategies, energy conservation strategies, energy efficient equipment, and also very famously electric vehicles, the built environment as a term has now become very bigger. So electric vehicle charging station will have a meter. Your rooftop solar PV with an inverter may have a dedicated meter to it. If you have a two-phase or a multi-phase connection, each and every phase may have a meter for it. So it becomes very crucial to understand the electrical boundary at which I can say that my particular building under study is a net zero energy building. So it requires the use of a defined site boundary. That is what is being, if you could look at to the definition, that is what you can grasp from it. The site boundary, what I'm talking about, it represents a meaningful boundary that is a functionality part of the building, right? Now, functionality part of the building is necessary to understand because the comfort of the occupants who are there inside the building should be taken into consideration. And whatever definitions I have presented before you do not talk about the occupancy patterns or the occupancy comforts, which is again one of the major, what I say, importance when you talk about having building conventionally as a whole. Because if we don't talk about energy efficient building and only about buildings coming through civilization, it is a shelter that provides comfort to the occupants or the inhabitants from the with respect to the outdoor environment. Having said that, even to achieve energy efficiency, what we have looked upon is in our research is that I can only provide the decision making strategy to the consumer rather than or give that particular consumer a price incentive to use better electricity in a good quality form or to adopt towards energy efficiency measures, but one cannot enforce the occupant, right? I may educate them as a policymaker, but I cannot enforce them. And that is the reason why the occupant's comfort needs to be taken into consideration. Now, when we talk about the occupant's comfort, the functionality of the building also takes into consideration because as per the ASHRAE standards also, the metabolism of a particular person who's there inside that particular building space would change depending upon the nature of activity. So if as an architect or as a designer, if I design an energy efficient building for a western part of India, and the same and that building is a gym where the nature of activity is different, I cannot use the same standard for an eastern part of India because India divided into 5 subtropical regions have varies the weather conditions and also how the particular occupant uses the building, for example the gym as well. So that needs to be taken into consideration, and that is what we have tried to attempt in the study that I am going to present before you. So coming back to the site boundary in the screen, which you can see that this figure on the left side shows the site boundary of energy and how it forms from the building energy, on-site renewable energy production, delivered energy, and exported energy. Exported energy is what is actually being calculated in the calculation of net zero energy rather than the on-site renewable energy production. So exported energy is the on-site renewable energy supplied through the site boundary and used outside the site boundary. That means which has been not being used by the particular built environment under study, but which has been given back to the grid. And of course, there are different strategies. Like if you go for in India, we have 2 types of strategies. One is the net metering strategy, where it is calculated over the complete billing period, over the complete 1 financial year. Or you can go dynamically through time to time, where you have different tariffs of what you call incentive, different tariff incentive. And if you are able to provide electricity back to the grid at times where the grid demand is more, but the supply is less, then the incentives are more. And if you are able to consume electricity when the supply was more in the distribution utility and the demand was less, even then the incentive for the supply is more. So at every hour of the day, we have grid injecting price and the price of electricity taking from the grid. So the building that the simulation studies that we have done is we have taken into consideration a all seasonal HVAC system, heating, ventilation, and air conditioning system, worked on the basic foundational analysis. So this is the benchmark, this is the basis above which I will compare with the strategy of grid interactive building energy system, which we have developed. Also, the building space has been worked geometrically. For example, if you look around you, you are geometrically sitting inside a cuboid, having 6 faces, 1 floor, and 1 floor and 1 roof, and you may have windows. So all these have been taken into consideration in each and every building element. Just like a wall behind me has been modeled as a 3 resistance to capacitance network, taking into consideration the fundamentals of the building energy physics. The occupant comfort considerations that we have taken is we have worked on a multi-objective optimization, where we have worked on a coordinated energy control and comfort management, where the objective becomes that we need to maximize the occupant's comfort in terms of indoor air quality, which we regard in terms of CO2 concentration in parts per million, visual quality or visual comfort in terms of the illumination level, lux level, and the building space air temperature. And the 2 energy systems that are focusing on having this set point comfort for the occupants are the HVAC systems and the lighting systems. For simplicity, we have transformed this maximization of a comfort function into minimization of a discomfort. We have done a case study for the very famous Indira Paryavaran Bhavan. It's a new office building for the Ministry of Environment and Forest and Climate Change, Government of India. This building set a radical change from a conventional building design. It is the India's highest green rated building. It has received 5-star Griha and LEED Platinum, and it was designed and constructed by the Central Public Work Department, which again is a central union government body, and it was completed in 2013. The special emphasis has been given on the strategies for reducing the energy demand, both design strategies, active strategies as well. And the energy loads of the building and the remaining demand have been met by the rooftop solar PV, as you can see very clearly from the almost whole of the rooftop has been covered with the solar PV panels, and this is the Google Earth image. And I encourage all of you to go through this website. These are free open source website where you can get ample amount of information about the case study, and that's what we have done. As you could see, it's a multi-objective optimization, so we will never have a single solution. We will have multiple solutions, a sample or a pool of solutions where we can take into consideration. As I told you, we cannot enforce the solution onto the consumer or the occupant, and they have been given with certain functionality. And if they want to work on highest comfort, they can work on that total energy consumption. If they want to reduce their energy, they have to compromise on their comfort as well.
Can you please
what
wrap
we
up,
have done?
Harish?
Yeah, sure.
Can you please wrap up in 1 minute?
Yes. So can I have 2 more minutes? I think I have 2 more minutes.
Yeah, it's just to wrap up.
Yeah. So I'm ending only. Thank you. So this is what we have worked without grid interactive building energy strategies, and with grid interactive, what are the savings we are getting? The savings per month are to the cost of 100 rupees, which is for one single building room. So if you have so many rooms for such a larger building, the cost optimization and the cost effects are more. the savings are more. You may look as if the saving is less, but may I also remind you that we have also worked in uplifting the occupants' comfort, so we are not jeopardizing it as well. I have now currently extending this version and working on the peer-to-peer power sharing strategy, where we will have buildings of different functionalities, a gym, institutional building like Indra Paryavaran Bhavan and other buildings, which may not have a good solar profile or which may have shading, but how can they have low dependency on the grid, which is majorly fossil fuel based, and can participate in the green energy scenario by taking the energy, electricity from their neighborhood building, which is completely net zero or positive zero, P0 building. So I'm working also now on to learning the social aspects, that is the socio-techno-economic analysis of prosumer-based energy systems, and then assess the energy and environmental aspects of the buildings. So that's all from my side. Thank you so very much for your patient listening. Back to you again. Thank you.
Thank you, Harish. That was wonderful. Indeed, when we talk about simulation and BIM, I think we just need to think about the buildings, but we have to think about neighborhood scale and district scale, because it's not working. And what I see from your presentation is that you are actually not doing a dynamic simulation. Is that correct, or am I wrong? Is it like you are calculating the sum of the energy consumption and put it in the kind of calculation methodology? Is that correct? Okay.
Yes, but for validation, we need to perform dynamic simulation in order to validate that my simulation model is correct. For that, we did dynamic simulation, and that is the paper that we got in applied energy. After validation, now I work on the static simulations, where for the whole month period, what is the energy scenario for a seasonal summer, winter, autumn, what is the scenario, and then annual.
Perfect, because I think it's very interesting also working with different building typologies and different number of buildings. So I think somehow there is a difficulty in the building simulation environment. Maybe Dr. Gülsu Hoca would like to answer that there is a problem in simulating multiple buildings on a dynamic scale. Is that correct? I think it's one of the most important barriers in the simulation engineering right now.
Exactly. I think it's a question, isn't it? Yes.
If you could,
right.
If you could kind of inform us what is the stage right now. Are some tools being developed to solve this problem, to take things into the neighborhood scale and also the city scale?
Yes, actually, interacting of the buildings with each other is also another problematic that we need to consider during calculating the energy performances of the building. So there are some new initiatives in the programming sector that they are just trying to cope with these problem in the neighborhood scale. It's also possible to make these simulations, but you need to consider different aspects rather than only one building. You should consider the several types of buildings. Somehow these buildings have different occupancy periods, etc. And also the environment, the microclimate is also important at that point to consider. So you should change the weather data, and the requirements for that data is also another thing you should consider. So there are some softwares, there are some tools that can make these simulations in the neighborhood model, but it is need to be improved.
I understand. And I guess also in artificial intelligence as well, perhaps Aydın Bey, this question comes to you, perhaps. Is it too early to talk about on a district scale when it comes to artificial intelligence in construction activities, or is there some hope still that we can use it properly?
All depends on the data from my perspective, from my point of view. Because if you have the data about the district and this data, is described is changing so fast. So we should have this data real time, and for the historical data, and we should work on it. Of course, this can be done because there's a infrastructure to do that from software development side or computer science side. But from the construction sector side, we have a time because we couldn't manage data properly. For the building side, we couldn't manage it, and for the big scale, we couldn't manage effectively. So I think because of that, first of all, we should focus on data management, how we can collect this data effectively, and to open services to software developers to develop new things. And I don't want to open that area because open technologies and that kind of things are so important for development. It was a long story, of course.
Okay, thank you very much. Yeah, Paula, please.
Can I just want to compliment, because I know that when you design a building, you do take environmental data, climatic data into consideration. Therefore, in my view, it's super important to have this correctly, and it's also super important to have this distributed in the city. Normally, you have the climate data comes from one source, one or two, and sometimes that isn't enough to assess the microclimates or the neighborhood climate. So it's actually, I've seen some research about it, but what I've seen is at the beginning phases, it is about the data as a quite correct.
Yeah, I agree. Data is one of the most important thing. And also, again, Aydın Bey, I would like to ask you one more question. When we were talking about CDE, Common Data Environment, so we were saying that there is this contractual problem. So I think, is it about releasing the data in between the companies? Or is it something different than what I thought?
Common data environment is so critical. I always talk about that because all parties are using different data silos. Architects are using different things, and the owners are using different. And contracts can't force people to use the same systems at the moment. So in that point of view, and every company start to protect their data, this is not good for develop new things. So we need more data. As I said, maybe we can come a point. We need open data ecosystem. We have to share data with the researchers. We have to share the data with the developers to make the better things. People can't reach data at the moment in the construction sector. In the UK, it's the same. I think in all over the world, it's the same. I think this is a very crucial problem to develop new things. If you try to make a research without the data, or if you try to develop a new thing without the proper data, it's not possible. For one company's data or one architect's data on one owner's data, is not possible to do that kind of things. We can read some data from, for example, the climate data, other country data openly, but it's not enough. We need more detailed data sources. So now we have a common data environment structure and standards in UK and Europe, but they are just in the planning stage, not effectively used on the construction site and then in the projects, unfortunately, but we are waiting for that eagerly.
Okay. I think this is kind of the end of the presentation, this session. I think we have a lot of things to talk about, but to the point that we come right now is I'm very happy because we started to say data more than just saying BIM and energy. So I think it's a very important, and it shows how we are catching up with the real world when we talk about data. So thank you very much, everyone. I hope we can meet again soon. Thank you very much for your presentation and participation. We are closing the session. Thank you.
Thank you so much.
Thank you.
Thank you. Bye.
Thank you.
Cheers.
Bye.